data that we can see in the solid model right now. And that is pockets, chamfers, and holes. And there's several new things going on with the chamfers and the holes. AHRM and AHRM both are going to go out and do what we call a parse on the model. They're going to analyze the model, and they're going to discover features within that model that are geometric, okay? And they're going to identify those for us. Now, pocket recognition is obviously going to look for those things that are identifiable as a pocket. Open pockets, closed pockets, and so forth, okay? All the pocket geometries are automatically discovered, but we're not going to force you into automatic generation of toolpath. We're still going to allow the user to edit the list and give you control over the toolpath. So this is more of a semi-automatic function, if you will. Now, going on down the line, depending on how the reception is here and what you guys give us for feedback, we may take this to significantly higher levels, or we may not, depending on what you guys want. Okay. Today, we're going to go ahead and show you a little bit about how the pocket recognition is going to work.
Okay, Ken, can I interrupt you for a moment?
Absolutely.
Okay, can you just show me your screen? It's just not seeing the screen itself. That's all. Thanks.
There we go.
There we go. That's better.
Okay, so two things that we're going to automatically capture in all of pocket recognition is going to be the upper and lower levels of all the floors. So we kind of take that away from you. You don't have to go into the levels and set those things right away. But we're going to keep control over the definition of the tool. We're going to maintain control over the technology that you define to use in here, and of course the cutting strategies that you use. So let's take a look at how this works in the system. We're going to start off with this part here. Uh-oh. Got it? Okay. We're going to simply come in here, and let me go ahead and bring the operations up. We're going to do a pocket recognition. Very simple. Assign the geometry. Few items that you can set in here if you need to. One of the first things we're going to do is we're going to identify what size holes we want to filter to. We do want to capture this hole, but we don't want to capture all the rest of these as quote-unquote pockets. So I'm going to drop this to 40 millimeters just to keep it underneath this size, but above all of the rest of them. Simply pick on the model. The system is going to go through and analyze and look for all of those features, as we said, that are identifiable as pockets. Now, some of you may have played with this a little bit before now. Not a whole lot done in here, some fixes, a few things that we've kind of cleaned up a little bit, but let's take it into where it's going to go. You can of course name all of these and then accept that definition. We're going to go ahead and choose a tool. In this case, we'll start out with a 25 millimeter end mill. Pretty much everything else is set for us.
Now, basically what you're seeing over here is that everything else in this operation is exactly just like your regular pocket operation. The geometry, though, this takes care of the depth, but everything else is just like your regular pocket operation with open pockets as well.
And as we show the simulation, you can see it automatically find all of those features. Now, you may also notice it kind of took a lap around the top there. I want to show you that, show you what we can do to control and correct those kind of things. Okay, so very quickly found all the different pockets, found their upper levels, machined them to their lower levels, and if we want to, we can always go back to the geometry page, and in the modify, we can simply exclude the top face. And then, when we rerun those, you'll see it does not no, it's still good. Hang on a second, Sid. What did we do wrong here? The man behind the curtain.
Okay, just go back.
Oh. Okay, go back. I turned it off. Sorry, my bad.
Okay. Too quick with the hands, Ken.
Okay, so, pardon me?
Too quick with the hands.
Yeah, too quick with the hands. There you go. All right, so the next thing we'll do in here is we're basically going to save and copy this. And the only thing we're really going to do is go in here to the tool. We're going to change to the 6mm tool. We're going to go to the Technologies page and simply turn on the rest material. So we've machined it with a 25mm tool. Now we're going to come back, identify that as the previous tool, save and calculate, and again, very quickly, we've got the remainder of the pockets machined out in here.
Now, what's really nice about this is you notice that all those little slots that the previous operation couldn't pick up, we didn't have to create a separate geometry for it. It was in the original geometry of the pocket recognition, and the rest material picked everything up and machined it out just like it was a regular pocket.
Okay, so very clean way of approaching this and very, very quick. Now, let's step back over into our PowerPoint presentation for a moment. Okay, come on now. There we go. The next thing we want to talk about is a new feature. This is brand new to the software. It's been released very recently. This is called chamfer recognition. What is the idea behind a chamfer recognition? Well, quite often we'll see models from our customers where the engineers didn't put in all of the chamfers for the deburring, and yet there's a blueprint call out that specifies that all sharp corners need to be broken. And so how do we go about doing that? If we were to set up profile operations, we would wind up spending quite a bit of time deciding where to cut, how deep to cut, what diameter of the tool to cut, and so forth. So what this product does is this actually goes out, finds all of those sharp corners, and then the user has control over the chamfer depth, what diameter of the tool we want to use, and the safety offset. What's the safety offset? Sid, tell us a little bit about the safety offset.
Well, the safety offset is very simple. If you notice that little picture that we have in the bottom right-hand corner, you'll notice that the tool path is actually coming up towards the wall. What the safety offset actually prevents the tool from coming up to the wall itself, thereby protecting itself from any gouge from the tool into the wall. So you can get as close as you want to the wall without worrying about damaging the wall. It's sort of a safety factor where you can define your entire geometry and don't have to do an edit geometry to get close to that area. It really, really works phenomenally well. One of the best features in there.
So let's go ahead and take a look at that. Again, we go to recognitions, simply choose chamfer recognition. We're going to go look at the features. Now, very, very simple. Again, diameters. We want to make sure we're cutting the right places. So we'll set this one in at 40. Select the model. Again, it's going to go through and analyze the model and find all of those areas where we need to do the deburring. We'll accept that. Go to our tool selection. Again, the user has control over the tool that they want to use. Levels are already set for us. We're going to set a chamfer depth here.
Right, you'll
so
note
you get to determine
there is no upper level.
Right. No upper level because the system is going to calculate all that for you. It's going to find each of these levels and manage them automatically. So let's say we wanted to do, for instance, a 1 millimeter chamfer. Okay. In our technology page, we can also determine what diameter of the tool we're going to use to cut with, and again, we'll set that up for a 2 millimeter. You also have control over this safety distance. So maybe you want to get really close to those walls, but keep the shank of the tool off of them so you don't wind up damaging the wall face. So we could set this, for instance, at a 0.2 millimeter. Very easy way of doing that. Save and calculate. Very quickly, the system computes each of those locations. Let's go ahead and bring this up a little bit so you can see it a little better. And runs around, does a nice little deburring path all the way around the part for you.
Why don't you zoom into one of those edges over there? Show them what it did there.
Yep. Let's go ahead and take a look over here. Notice how the tool stayed off of this wall here. So we don't have to worry about shank rub up against what might be called out as a sharp corner requirement on the vertical. Okay? Very, very clean. And you'll notice you'll see that everywhere around the model where it comes up against the wall. Okay? Okay. Let's go ahead and go back into our PowerPoint for a moment. Drill recognition, another one of our automatic feature recognition capabilities. Now, drill recognition, again, I would consider a semi-automatic operation. This is going to give you some real benefits, and there are some limitations to how it can be used, how automated it is, but it gives you some really good functionality for doing some very specific things. One of the things that we really like to do with this is controlling multiple spot drill diameters with a single tool with a single pick. Okay? It also supports all types of different holes simultaneously, different spot diameters. And we can do it with a single tool on multiple levels without having to fire a new operation in doing this. Okay? So again, let's go out, take a look at the program. Now we're going to do drill recognition. Again, a very simple function. Identify a coordinate system, assign your geometry to it. Sid, where do we want to go with this?
Well, what we want to do is actually, you notice those really big holes over there, we don't really need to drill out because we already machined them out. So we have a filter over here for our hole diameters. So why don't you just click on the hole diameter filter and go into the tool and click on the largest chamfer countersunk hole that you have over there.
Right. This gives us the ability to set a range of holes that we want to work with by simply finding that hole on the screen, okay? And it identifies where we want the tool to work and where we don't want the tool to work. So it's very, very simple. Go in and find the holes, and as you can see, the system very, very quickly found 3 different shapes here, okay? Now these shapes are this series of holes here, and this is leading into what we're going to show you here in a few moments with the automatic hole recognition and machining. This is a little bit deeper into the modules. But notice that we found a particular shape here. That shape is made up of several groups, and each of those groups are made up of individual holes. Okay? And so as the system recognizes all of these different features, it now knows what it needs to do with each one of those. We can accept that. Again, the tool selection is up to us. We get to choose what we want to do. We're not limiting the user and forcing them into an automated strategy. We're allowing that user to go in and say, I want to use a 16 millimeter spot drill. Okay? Again, the levels are taken care of for us, but we can go into a depth edit if we want to. We don't need to worry about the upper levels. The system automatically finds all of that. Now, if we set this in the depth type to the auto chamfer spot drill, it's going to know what we're trying to accomplish here. We can also then look at the chamfer depth, and we can leave this set for 0 and make sure that we assign that to all of the features.
Now, one more thing, if you want the automatic chamfer to be on all of them, when you click on automatic chamfer, we also have the option of all at the bottom. By clicking all over there, and the same thing with the chamfer depth, clicking apply all and apply, it applies it now to all of the holes as well. So it picks up the diameter of each individual hole and knows exactly what chamfer size to get to.
And we still have the opportunity to determine what cycle we want to use. So maybe we want to put a G82 in here. We can determine things like the dwell. Maybe I want a 0.2-second dwell on each one of them. Okay. Not a lot of work to do in here. Save and calculate. Up we go. Okay. And notice all the different sized holes, each one of them chamfered to the proper location, regardless of the level that they started on, regardless of the diameter that they're meeting. Okay. So again, a very effective way to do something real quick. Go ahead, Sid.
Yeah, well, what I'm going to say, I mean, just for the issue of the spot drills itself, this was always a very tedious operation. Everyone always wanted to do operations for spot drills, and because of the different levels and different diameters, you would have at least 6 or 7 different operations you'd have to create over here in order to do this correctly. As you've seen what we did just now, in a few short moments, in less than a minute, we created all of the operations for every single one of those holes to their exact size.
Yes. Yeah, Sid, if you got a different headset you can get on instead of your microphone, you're breaking in and out a little bit on us.
Okay, I will put on my headset instead.
Okay, and I'll go ahead and continue here. All right, now, the next thing we want to talk about, and this is really powerful. We've done a lot of work with this. As I said before, kudos to interested in that. We're going to show you what you can do with this and how you can really make this work. As I showed you earlier with the drill recognition, same engine, it's going to classify the shapes and groups of holes. So this automatically goes through and finds the geometry. This also automatically selects, and this is critical, and or creates all the required tools based on the data structure that you set up. Okay? You're going to see how that works. It also builds intelligent machining technologies. We know what we want to do under certain conditions, and it'll automatically create those for us using the machine process engine. Okay? And it generates the multiple machining operations. Now, this also does some pretty cool stuff in that it supports multiple work positions. We'll show you that here in just a moment. Let's take a look at what this looks like in action.
Ken, do you guys hear me well now?
Yes, much better.
Okay.
All right, now this is a fairly simple part. I want to start with this, and then we're going to take a step into the next level. And Sid, I'm going to throw a little curveball at you too.
Oh no.
Oh no. All right, what I've done here is I've set up 2 coordinate systems.
Oh boy.
In a 3D toolpath, you need to pre-assign your coordinate systems in a 3D machine. And we'll show you why. We'll show you what's going on with that. But I'm going to go in here and I'm going to say I want to do hole recognition and technology. Notice we can choose from several different database structures. We'll get into this a little more in detail in just a little bit. But I'm going to go ahead and use the system hole recognition database. And notice again that it went through and it parsed this model. Okay? You can also re-recognize here by doing a right click at the top of this. And it'll go back through and re-parse it if it needs to. So be aware that there are some things on the right mouse menu. Now, notice again it found several different shapes around this part. Okay? And each of those shapes are made up of groups. Each of those groups are made up of individual holes. Each of those holes are made up of individual segments and so forth. Okay? So this is the recognition engine right here in the browser. The next icon over here is building the M features, or the machinable features. Okay? So when we click on that, you'll see basically the view doesn't change a whole lot as far as the shapes and groups, but it has classified each of the individual geometry segments into machinable features. Now this is where it starts to get really powerful.
Ken, just a second. Why don't you just show that at the very bottom of that group, VM features?
Oh, back here?
Yeah.
Yes,
Just so
good idea.
Right. When you click on the shape, it shows you exactly what that shape is, what it has. You go to the drill in the thread for that in that case.
Okay. And so you get to see each of the different types of segments that it categorized. Now when we go into the feature sets, it's going to organize these by the available coordinate systems that it has the ability to work with. So you'll notice it has a Mac 1 and it has a Mac 2, and they're organized under the ones that are achievable within that orientation. By going into the next set, the technologies, this is going to build the different groups of technologies, and you'll see down here that it's actually created the operations necessary to machine each of these different holes. Okay? And then we simply go here, and it actually generates the toolpath. Now, what's really cool about this is it's very, very easy to simply step back here, come down to feature set 2, right-click and make that my current, go back and assign those technologies, go back and assign those toolpaths, and now it has created both sets of toolpaths automatically for me, and generated all the necessary tools, guys. That was an empty tool database when we came into this, okay? So the system automatically determined what tools it needed, determined what toolpaths were required to machine these features, and what machine position orientation it could or couldn't work into, okay, based on what we had pre-created. So a pretty powerful way of running this. Let's go ahead and take a look at this in simulation. Okay. You're ready to post code. Not too bad. But let's take a look a little bit deeper. What if it gets a little crazy on us? Now what do we do? Okay. Now we're looking at a situation where we've put this on a 5-axis machine, and we want to go in and we want to machine all of these holes, and we want to do it quickly. All right. So again, I want you to notice an empty tool table. Okay. I also want you to notice we have a primary coordinate system, the main machine datum. All right. Now we're going to go into our operation set again. We're going to simply say I want to do hole recognition and technology. We're going to go into the SHR. It's going to go through this, and it's going to look at this entire model. It's going to find all the geometry segments in here that are available to it, and it's going to go ahead and organize those into those groups that we talked about. I simply take a walk through these, just like we did before. It assigns the machine features. It assigns the sets. Notice in here that there's several different sets. Okay. Assign the technologies. And then assign those toolpaths. A lot of work going on here. Now let's take a look. How about that, guys? Look at what it has done here. It automatically assigned all my work positions, and with a unique little default setting, we can automatically assign them all to CoordSys 1. So we don't have to worry about them all being placed all over the place. We get them coordinated where we would normally use them for a 5-axis operation. It also created all the tools that I need. Okay? So then when we go in here, let's go do some machining, including all of the 5-axis positional orientations, okay, with the appropriate tools, with the appropriate depths, with the appropriate start points, the appropriate end points, everything taken care of for you that fast, okay? Isn't that fun? We've been having an absolute ball for the last 7 months. Okay? And again, I will say this over and over and over again, our development team is fantastic, guys. They have really put some effort into this. Okay, well, what could be next?
We did say we're going to save the best for last.
Got a little bit more to talk about, though, on this first, because one of the things that we've heard from people over the years is that this is complicated. This is tough for the users, okay? We put a lot of extra effort into this, trying to find a way to make this more usable and easier to function with. What you just saw happen there, by the way, is the installed database in the system. That's not a special database. When you install our system, that's the one you get, okay? So, several things can happen here. You can define as many databases as you want. It's an unlimited number of them. Save as, and away you go. Notice we put a little Save As button down here in the bottom for you. So now you can go in here, do a Save As, give it a new name, play to your heart's content, okay? You can select any of them for the process that you want to use in the current process. Guess what that means, guys? Now you can go in, if you want to, in your data structure, you can hard code all your feeds and speeds, tool selections, and so forth based on a material set. Now you can do a Save As, simply go in and update those tool feeds and speeds for a different material, depths of cut, so forth, and now you've got an additional database you can use for aluminum, steel, titanium, whatever you're cutting, okay? You can edit the part database independently. I don't know if you noticed, but when I picked that technology, one of the selections in there was the part database. Even though I use the system hole recognition database, when it creates that first function, it inherits that database internally to the part file. Now in the part project, you have an independent database in there that you can adjust without adjusting your global database that was installed. So you've got several different levels at which you can do this. And of course, you can save the active database as a new one. Something else going on here, guys. This means two things for us. Resellers, a little customer support here, okay? As the customers start to play with this, you're going to need some techs on hand that are going to be able to understand this. We'll help you with all that. But you're going to want to be able to understand what the customers are doing, and they're going to ask you some questions. This is all documented very well. We'll cover all that in the tech session. There's a lot of documentation on this, a lot of information available to you. They're going to want to help, you're going to want to be able to help them understand how to modify a copy of database and where these technologies are stored and so forth. So there's a minimal effort needed from you guys if you want to support this and sell it to handle the customer support. But here's where it really turns into something powerful. You can generate revenue off of this. Most customers, quite honestly, unless they're very involved, are not going to want to dig in and build their own databases. So you as a reseller can sell the database services, okay? You develop based on their specification, you can build a database to meet their requirements and their needs. You can sell that as money. You can also sell training classes. For those customers who do want to dig into this, there's an opportunity for you to build training classes around this, okay? So there's a lot of real heavy-duty power here. Sid, you want to add anything to that?
Besides all that, there's all the webinars that I'll be doing, and I will be doing webinars on this subject for the resellers as well, to help you also get up to speed. And if necessary, do any kind of training you may need on this. But one of the things that this is a really extremely powerful but easy tool. And this is what they call total automation. Once it's set up correctly, it's total automation.
Yeah, we just generated 140 toolpaths in under a minute. Not too bad. Not too bad at all. All right, as Sid said, we're going to save what we kind of think is the best for the last. Now, this is something that's brand spanking new. And again, and our developers have really pulled out the stops on this one. Okay? SolidWorks has had a whole wizard for many, many years now. We've not been able to really take advantage of it. Now we can. Now, this is a first step. What's that old saying? Journey of 1,000 miles starts with the first step. Well, we've taken several steps. Okay? We got something ahead of us that can be very, very cool. And we're going to keep working on this. We're going to continue to improve it and so forth. But let's take a look at what we've got here. The whole wizard from SolidWorks has a whole series of what they call extended data set parameters that are available via the API, application programming interface, for those that don't know. We can capture those whole wizard parameters and take advantage of them in the machine process. Now, we're looking at two different scenarios here. Let me describe a little bit about what we're talking about. What we just showed you with the AHRM is more of what I like to call a noun-verb command structure. We found the items that we wanted to work on, and then the technology decided what action to take on those items. That's your noun and your verb. Okay? This methodology is slightly different. This is a methodology that I like to call a verb-noun structure. The machine process is going to describe the actions that we want to take, and we're going to go select the items upon which we want to place those actions. Okay? So it's a little bit different than what we just saw in the AHRM, but this is really powerful. Geometries are also available now. Okay? One of the limitations of machine process in the past, especially for drilling holes, was we couldn't come in a circle mill because the only thing we really had was the center location. Now we have all the geometry entities within the whole wizard. And, again, thanks to our fantastic tech department and development department, we have conditional logic in the expressions. And again, we'll go into detail on that tomorrow in the tech session, but this is really, really powerful. It supports all types of whole wizard types. Okay? We pick up the near countersink, underhead countersinks, far countersinks, head clearances, and so forth. All of that information is now available to the machine process, and we can take advantage of that to make a very, very automated machine process. And it also supports blind and through conditions, so we can make different conditional decisions, whether it's a blind hole or a through hole. Okay? As I said, the geometry entities are also now available. They never were before, okay? But now they are, which means we can do pocket and profiling and assign those as part of our strategy. Now, what we discovered along the way on this, and this is what's kind of cool about this whole process, I've thoroughly enjoyed working on this for the last 7 months. As we get deeper and deeper into this, we begin to discover more things. Lo and behold, we went in a couple places and changed the counterbore diameter. It automatically updated. It was really cool. We had full associativity. Now, we don't have full associativity in all aspects of it yet. We're driving that direction. We're looking for ways that we can do that. But let's take a look at what we do have right now with the conditional logic that's available that allows you to make decisions based on what the values and the conditions of those parameters that we can now find are. Okay, so again, we're going to go back out here. I'm just going to open up this other file. Now, this is a pretty simple file format here, but we want to show you a couple things in here. So we've got some different threads in here. This is kind of the area where people have asked us, you know, the whole wizard already knows what the thread is. Why don't you guys? Why do I have to pick the tool? Okay. So what I'm going to do, once you assign the machine process, and we've already got a couple in here, these will be installed with the system. So you're going to kind of see what the basic machine process is and what's involved in this. How many people in here have ever worked with machining processes? Show of hands. A couple of them? Okay? What was the toughest thing you ran into? Building all the multiple sets, default sets? Because we couldn't make logical decisions, and so in order to facilitate all the different conditions that we would see, we had to build this huge array of default sets in there and lock everything down, right? Wait till you see what we got going on here. I'm going to go into add machine process from the MP table. I have 4 processes in here. Let's start off with the tapped holes. So I'm going to simply double click that. Here's my operations template. We have 1 default set, guys, 1 MP. Notice how little is shown here. We're going to go in here and we're going to recognize geometry. We're not going to select or define it. This is actually using the whole recognition engine to determine this geometry. So I'm going to say I want to recognize this hole. And it's going to capture that hole for me. I'll show you something in there on the next one in as well that I want you to pay attention to. I'm going to select the top of the hole. Notice what we've got here, guys. It's associative even. Okay? And that's it. I'm going to say insert. Done. Let's take a look at what that did. Number 1, chose my tools. Okay? The tap that it chose, 6 millimeter by 1. Let's go back in here and take a look at our part for a second. Okay? Let's go into the edit mode. 6 millimeter by 1. Okay? So it recognized what we were doing with it and picked it up. Now, to take us back into the model, simply going to start that again. This time I'm going to stay in here. We're going to run this again. Now when I go in to recognize this, a couple other things in here that again have been done for us. You can use a single hole. You can pick the entire wizard hole set. Okay? So there's going to be several different locations within that parent feature. Okay? Or you can also pick all patterns that include that feature. And we'll show you in a few minutes that that's extremely powerful. So I'm going to come over here and pick this one. By the way, we also have a dump file in here for those that are going to be doing technical, building these strategies. You can pull the dump files, kind of like the trace file in a post. It allows you to see what's coming through, so you kind of know what parameters are getting set where. Go ahead and accept that. Again, all I've got to set here is the Z value for the top of this, and I'm done. We'll insert that, and then look at this. I can just reset, go to the next one, recognize it, pick up this hole, accept that. Could be at a different Z level. We just did this as kind of a simple file for you. You don't have to pick this if you know it. You can also pop the 0 in there if you want. I like picking it just to make sure I'm capturing the actual model data. Insert that one. It built all of those. Reset it one more time. Remember, we're talking about a verb noun action here. I'm deciding where I want to apply these actions, not the system. So, go back in here, select that one. Again, set its top Z. Insert that one, and away we go. Okay? Now, let's take a look at what happened here by going into simulation. We're just going to leave this in the HostCAD simulation, and we'll roll this over to an even view here where we can watch what's going on. A single step it through. Notice it found the right size spot drill. Also brought the spot drill to the right dimension for the upper chamfer, the near side countersink. Found the right size drill. We set it up for a G83 PEC cycle. Okay. Notice on the blind hole, took it exactly where it was supposed to be. No overshoot, no undershoot. Okay. tap. Okay, notice the tap came down directly to the thread level, right where it knew it was. So it knows the thread depth from the hole wizard. We didn't have to set any of that stuff. In the same default set, it now went to the next hole, discovered that, guess what? It can use that same tool, same spot drill fit. Brought it to the correct dimension. Proper tool depth. Brings the drill in again, another blind hole, knows to go right to the depth of the hole. This is where it gets pretty cool, guys. Let's take a look at what it does with the tap. The user can define the chamfer length at the end of the tap. That's one of the things that we left exposed in this data structure. We also set up, I did that too fast, sorry. You notice it didn't go below the bottom. It did not come to the full thread depth because doing that would have shoved the end of this into the bottom of the hole. We automatically built a condition in here to look for the differential of this and keep it up off the bottom if it would go too deep. That's not bad. That's pretty darn powerful. All straight out of the hole wizard. Okay, some pretty cool stuff. Now let's go to the next one. Different size spot drill, took it to the right depth. Okay, let's walk this one down. It knows it's a through hole. So now it's going to go ahead and use delta to push through. User-defined amount. Okay, none of this automation is forcing the user to do anything. They've got total control over this, and when this is built, it becomes a standard operation just like anything else, and it can work it. Okay, and that brought, because the head could clear, or because the tip of the tool could clear, it brought it all the way down to the full thread depth. Okay, now, even a larger tool. There's conditions on the spot drills. We'll show all that tomorrow when we do the tech. Walk you guys, anybody that's interested in this, we'll walk you through all the stuff we've done in this to make this work. Again, drill comes down to the right level, pushes through. Now let's watch this tap. Okay, tap goes all the way down because it knows it's a through hole. It knows it can take the thread all the way through and push delta through to make sure we clear that extra thread and we're not leaving a dead thread at the end of the hole. Okay, pretty powerful stuff here. Not too bad. But let's take it up one more notch. Let's go to a real world part here. Lots of different styles of holes, lots of different depths, lots of different elevations, different conditions of the holes and so forth. Notice again, no tools. Okay. Now I'm going to go in here and we're going to do add machine process. Let's do the tapped holes first. So we saw how that worked. Again, I'm going to come in here, recognize the geometry. So I've got a tapped hole set here. Notice it picked up the entire set, all the patterns and everything. Now, these arrays, I'll show you in just a moment. These arrays were done with multiple features in each pattern. Some patterns were done on a single set of features, and some patterns were done with multiple sets of features, including some of the extrusions. So it knows to pick those holes out of those patterns and use only those hole locations that are identified as being a part of that particular hole wizard feature. Okay? That Z value pick is down on this elevation. So I'll insert that, reset this. Now I'm going to go back in. I'm going to recognize this little bitty hole here. Okay. Notice again, it found all of them, including the patterns over here. So it knows that this whole set was patterned over to this on a circular array. Again, a different Z level here, so I need to pick the start point there. Okay. Now, we could go through and do all the rest of the taps here, but let's go ahead and exit out of this right now. And let's go back in and let's pick a different one. Now we're going to use counterport technology. So now, a few different things that we need to run in here. But basically, as you can see, I'm only picking two functions. I'm going to come find that hole. It's going to calculate all those locations for me. Accept that. Pick the Z value for that level. And away we go. When I insert that, I want you to notice it includes a counterbore profile. It's actually circle milling the counterbore, and it's circle milling the upper chamfer. Okay. Do a reset on that, and I think we got some upper counterbores over here as well. So reselect those. Insert that, and we're ready to roll. Okay. We can exit out of this again. I should have stayed in there, sorry. My bad. And we can do countersink holes as well as simple holes. Okay, so you can build these sets up to be as big as you want them, or as complicated as you want them, or as simple as you want them. If you want to hard code everything because you know you have a specific strategy that you use for a certain type of hole, you can do all that now. But you can also capture everything straight out of the hole wizard. Let me go ahead and jump over here for a second. Again, builds all the tools automatically, but it does not replicate the tool. Remember in that one, the 10 millimeter spot drill was used in two different holes. It didn't create another one. It found the one that it already created, recognized that it met the criteria for that next hole, and used it instead. So if you want to pre-populate your tool table with tools that you know are going to fit your strategy, it'll use those. If you want to find out what tools are needed to do the strategy, they'll build them for you. Okay? And let's take a look at this in simulation. Okay. So lots and lots of functionality going on here, guys. Again, I'm just as excited as I can be about what our development team has done here. Sid, you want to add anything to that before we jump back?
Yeah, just one note on the counterbore holes. If
Oh,
you
Sid.
note, sorry, I was on mute. Okay. If you just take one quick look at the counterbore holes, you'll see there are two different types of counterbore holes. One counterbore hole has a countersink on top, and the other one does not. In one operation, one machine process, we were able to take care of both of those situations.
Right. So what he's talking about there, if you'll notice, these don't have a countersink up on the top. This has a near side countersink. This does not. Okay. However, when we run this, let's see if I can figure out which one that is. That one's that one right there. Let's do the. Yeah. So there's the spot drill for that. And let me go into. Come on, eyeballs, where'd you go? Let's just go into the host CAD simulation. We'll put this in wireframe. Roll it up here on the side. Okay, there's our hole with the sharp corner here. It even knows. Let's see, that's the, hang on a second, I grabbed the wrong one. Let's see, upper one, where I miss it. Is that it? What's this? hardest part of the whole thing is finding the toolpath that it created. Okay, I think that's the spot draw I was looking for right there. Okay, so no, I think that's the internal one.
You need the. Take rid of that.
Must be the profile.
Two more down. Seaboard profile.
There we go. There we go. Sorry about that. Okay, that's the seaboard profile on that, and this is the circle milling. There we go. There's the one I'm looking for.
Right, and the one underneath that.
All right. It took me a moment to find it, guys. Okay, so we'll line this guy up. Yeah, you're right. It's the one underneath it, isn't it? Yep. Okay, so let's go ahead and simulate this one. And we were talking about it circle milling. So it comes in with that chamfer mill. And we may not be able to see it from this angle. I'll probably have to go to a different angle, sorry. Let's go over here and look at it. Okay, see that right there? Built in enough to go in there and break that corner. Okay, all of that done within the technology that it's using to do that, all automatic, and yet at the same time, if a countersink, near side countersink exists, it knows to use that diameter without overshooting. Okay, and again, tomorrow, when we get into the technical on this stuff, we'll guide you through all that and kind of show you what we've done here. Okay, so basically all that to say, doing a lot of continuous improvement, guys. A lot of continuous improvement here. More automation and power, quickly getting code out to the machine, and helping you figure out what tools you need. Okay. And I quit in time to go get some lunch. Thank you, Sid.
Thank you very much, everyone.
Thank you very much, everyone.